Hi everyone, it's us, Ian and Kian again. I'm sure you all have seen the carbon capture pilot plant in our department. But do you know how carbon capture works in pilot plant?
The answer is by absorption using amine solutions. Amines are being used in the carbon capture process because they generally have good CO2 loading capacity as well as can be regenerated by heating.
Absorption is the removal of volatile solute from gas stream by contacting it with a liquid solvent in a countercurrent way. It's usually used to recover low concentration component from gas stream. To perform absorption, a carrier gas with solute and liquid solvents are required. Carbon dioxide absorption process could be carried out in both plate and packed column. In this video, we will be performing carbon dioxide absorption using carbon dioxide in nitrogen gas and aqueous monoethanoamine solution, which is known as MEA, in packed column. We can perform the same process in the plate column too.
Both packed and plate columns are actually very similar in terms of their setup, with the gas enter at the bottom while the liquid flows down from the top of the column. However, we need to consider several factors before deciding on whether to operate by using packed or plate columns. This is a dilute system as the relative concentration of CO2 is low. In our case, the carrier gas is nitrogen and the liquid absorbent is aqueous MEA solution. The solute to be transferred from gas to liquid is CO2. There are two types of absorption, physical and chemical absorption. This is a chemical absorption because aqueous MEA reacts with CO2 chemically.
We are using packed columns to perform carbon dioxide absorption. And here, the random packing called ProPack is irrigated by the downflowing amine solution. Its weight surface can now provide a large surface area for interfacial carbon dioxide mass transfer. At the same time, ProPack has a high void fraction of 94%. Thus, it allows for good vapor flows while maintaining small pressure drop across the column. During absorption, nitrogen gas with carbon dioxide enters the packed column from the bottom, while the aqueous MEA solution flows down from the top. Both streams flow in a countercurrent way.
There is a flux of CO2 transferred from nitrogen gas into MEA solution during absorption. CO2 then dissolves in liquid and reacts with MEA solution to form carbamate. As the absorption proceeds, the concentration of CO2 in gas stream decreases when going up the column. We can measure their CO2 outlet concentration using a probe connected to a CO2 sensor at the top of the column. On the other hand, the concentration of carbamate in MEA solution increases when going down the column. So, are both gas and liquid streams in equilibrium at any point along the absorption column?
No, both streams are not in equilibrium at all. In fact, the displacement from equilibrium is the driving force for mass transfer of carbon dioxide to happen. From the data we gather in the experiment, such as concentrations of carbon dioxide, we will be able to conduct McCarthy analysis for plate column.
Similarly, we can measure the number of gas transfer units for the packed column in the later stage of your course.
That's the end of our video for this episode. Thank you for watching.